So we want to find the x-intercepts and multiplicity that goes with each of those. The y-intercepts, so that should just be 1, singular. There's only ever going to be 1. The degree and the end behavior of this equation right here. So we see that there are going to be 4 x-intercepts, and some of them have higher multiplicity and some of them don't. Remember, to find the x-intercepts, you take each factor and you set it equal to 0. So this one would literally just be x equals 0. And there's not even any solving to do there. So the x-intercept is 0, 0. And there's only one of those because we don't see an exponent up here or anything. So we just assume that there's a 1 right there. Okay, for this one, if we set the factor equal to 0, if we set x plus 3 equal to 0, and we solved it, then we would get x equals negative 3. So the x-intercept there is negative 3, comma 0, and it looks like that has a multiplicity of 2. So this one that says x minus 5 is going to be at positive 5, so 5, 0. That has a multiplicity of 1. And this one is going to be at negative 2, and that has a multiplicity of 4. Okay, so to find the x-intercepts, we basically set y equal to 0, and then we set each of my factors equal to 0. To find the y-intercept, we're going to do just the opposite. We're going to set all of my x's equal to 0. So if you put a 0 in here, you're going to have basically just 2 to the 4th left over. If you put a 0 in here, you'll just have a negative 5. If you put a 0 in here, you'll have 3 squared left over. And all of these numbers are multiplying. So right now that would be a pretty big number. 2 to the 4th times negative 5 times 3 squared would be a pretty big number. But then we see this x right here. And remember that if we're finding the y-intercept, if we're looking at what's on the y-axis here, my x value is 0. So if you put a 0 in any of these, it doesn't really matter what these 3 numbers give you when they multiply, because here's another 0 that you're going to come through and multiply this all by. Keep in mind that all of these numbers are multiplying, so if this number is a 0, it doesn't matter what these other numbers are. The whole thing will end up being 0. So the y-intercept is going to be on the origin as well, just like that x-intercept was. So they happen to be the same point because they're both equal to 0, so it's both an x-intercept and a y-intercept. To find the total degree of the polynomial, we want to add up all of the powers of x that we see. Keep in mind that even though this x doesn't have an exponent, there's still one of them there, so we still have to count it as 1. So here's 1, and then there are another 2 here. So altogether this is 3, and then we have another 1x here, 4, and then we have another 4 here. So the total degree is 8. And the end behavior is based on both if the degree is even or odd, and then what the leading value is here, if it's positive or negative. Remember that if the leading value is even, your ends of your polynomials are going to do the same things. They're either going to both go up or they're going to both go down. If my leading number out here is positive, well then they both go up. So as x approaches negative infinity, f of x is going to approach positive infinity. That's going up. So as I'm going to the left, as x goes to the left, my f of x is going up. And as x goes to the right, to positive infinity, f of x also approaches positive infinity. F of x also goes up. So this is showing that both of my ends are going up because I have an even degree polynomial and my leading coefficient is positive.